Welcome to our study series once again. It's been a roller coaster on AWS Cloud Security West Africa User Group this year. The study series has been amazing, beginning from the first day when we had Dr. Anil. We had seasoned engineers from Promise Wachuku, Imo Etuk, we've had Prosper, great deal of engineer. And today we have a seasoned cybersecurity community builder who has contributed to the development of the community. His name is Oreolua Jatao. He'll be speaking to us on container security. And in the world of microservices today, you need to talk about container security. You need to talk about your orchestration. You need to look at how security in depth. And as our topic today, he'll be speaking and giving his experience on that. So I just want to know where you are joining from. I want to know where you are connecting to us. If you are from anywhere part of Lagos, Nigeria, maybe from Britain, from US, would like to know where you are joining from. Let us know. Let us know. And it's a pleasure to have you be part of us today. And before I bring on the speaker today, I would just like to mention in a bit that we have the community day, which will make a further announcement. But the community day, October 16th, 17th. Please, do register. Be part of it. It's going to be massive. It's going to be where innovations, ideas within the African ecosystem, Nigeria and globally, will be discussed. And so. I would like you to, register and, be part of the event. Also, uh, I would like you to, mention where you are joining us from. Is it from Lagos? Is it from Ibadan? Is it from Abuja? Is it from London? Is it from America, the United States, or any part you are? Would like to know where you are joining from. Uh, it's our What Study series, the 16th of it, since we began, and it's been amazing. And so, as we mentioned where we are joining from, I would like to invite, bring on stage the speaker for today, a seasoned security expert and a community AWS community builder.
Hi, Gunle. Thanks for the warm welcome. Can you hear me?
Oriel Olua. Yeah, I can hear you clearly. It's a
Okay,
pleasure
okay.
having you.
Oh, nice. Yeah, likewise,
Yeah.
likewise. So it's a pleasure being invested in the community. So it's a pleasure contributing to the community. I'm definitely happy to be here. It's always great to be
Yeah,
here.
it's a pleasure. Oh, we have we have someone from Lagos, IJ. Oh, it's a pleasure having you on this study series. It's a good one. I know you'll be greatly, in terms of knowledge gained by the time our speaker begins to go deep into security, begins to talk about life cycles, talking about container security tools like Falco, AWS Inspector, and I, I you will indeed be be one of great learning and pleasure to be part of it. If you are joining us, let us know. Let us know. We just have a few minutes before our speaker begins to take us down the journey, and I will go backstage to take notes. And because as someone who is interested in security, applying security within the company wherever you work, it's one of that I'm really impressed to be part of. We just have a few more minutes, and our speaker will be speaking. Let us know where you are joining from. Let us know where you are joining, whether it be Lagos, Abuja, Ibadan, London, United States of America, or any part of Africa. Please, Okay, so it's 6:05, and I would like to bring on stage our speaker, Orelua Jetawo, to begin. And so, Ore, you have the floor, and you can begin to share your screen and begin to speak to it.
All
Thank you
right.
so much.
So let me know when you can see my screen.
Yeah, we can see your screen clearly.
Okay. I think I can
Let me
do
go backstage so that you
presentation mode.
have.
Um,
Okay,
just give me a second. Trying to. Okay. Right. Okay. Good evening, everyone. Um. Like Kuni had said, it's really nice to be here. So today we are going to be talking about implementing runtime security in Amazon EKS using CNF Falco. And as Ambassador had mentioned, my name is Rarilo and I'm a community builder. Um, so in general, when we talk about Kubernetes security, right? A lot of our attention tends to go into what happens before the deployment. We scan our code, um, we scan our container images, we check for vulnerabilities, enforce policies, hopefully deploy something secure, right? But here's the question I want us to think throughout this session. What happens after container starts running, right? If someone opens, or rather, if someone compromises that workload at 2 a.m. and start executing commands inside the container, how do we know? So that's the problem, right? That runtime security is trying to solve, and that's where Falco comes in. Um, so basically, this session is going to divide into two parts, right? First of all, we're going to understand what runtime security actually means, where it fits into Kubernetes security. So you might hear me say Kubernetes, you might hear me say K8. I'm literally saying the same thing, and literally how Falco works underneath the hood. We'll talk about Falco rules. We'll talk about its infrastructure in EKS. Um, but at the same time, we don't want to be purely theoretical, right? So within the second half as well, we are going to actually go into deploying Falco in an actual EKS cluster, generate suspicious activities ourselves, and actually see whether Falco catches us, right? Um, so moving on to the next slide. So let's start with container security lifecycle. Um, at the code stage, we have things like static analysis scanning, secret scanning, code review. During the build phases, we have dependency scanning, software composition analysis. You're adding your base images, you're using a very, very lean image. At the registry level, you are scanning those images, you're looking at CVs, you potentially are right, preventing images from having unacceptable vulnerability. So you have your threshold. If you scan an image and an image is at a critical level or critical level severity, medium, high, you want to block that from going to production, or medium, depending on your business policy or the business use cases. At the deployment stage, Kubernetes gives us rule-based access control, network policies, port security standards, etc. So basically, they are primarily going to stop something bad from getting into our environment, right? But then when the application starts running, that's where runtime comes, or rather, that's where runtime begins. Um, Now, a container image being secure when it's being scanned, right? It doesn't exactly guarantee that the workload will behave securely when it runs. That's the gap we're trying to focus on today. Um, Now, let's move into what exactly is container security, or rather, let's move into what exactly is runtime security. So, simply put, right, in layman terms, we're monitoring what the workload is actually doing while it's running.
Well done. All right, please, can you put it in presentation mode? It's
Okay,
still, yeah, so that everybody can have. I'll
okay,
go back to it so that it's easier for you to everybody can see without.
all right, sure. Just give me a sec. think I'm trying to put in presentation mode, but it's just not.
You were in presentation mode before. You just. I think you
Yeah, I
F.
tried it, but I lost access to my other screen. That's why. So, but is this better? Let me
Okay,
let
let's
me move
see.
this.
Okay,
How about this? Is this better?
I think it's better now.
Okay,
It's better.
okay, great.
Okay.
Thanks. So, as I was saying, right, imagine I deploy an NGIS container. Starts normally and is serving traffic. Suddenly bash starts, or someone is trying to read etc shadow folder or file rather, or someone executes a binary, or suddenly a container is trying to make outbound connection to a malicious IP address that it has never contacted before. Now, these behaviors may indicate that something is wrong. Um, and I think I enjoy, or I really enjoy the distinction that I've made down here, which says image scanning will basically ask what exactly is inside this image, right? But runtime security is going to ask what is this workload actually doing? These are these basically are two completely different questions, right? Um, and why exactly do we need runtime security? So I want us to make this extremely practical and conversational, right? Um, Now imagine our security pipeline is extremely perfect, right? We scanned our images, there are no critical vulnerabilities, no high vulnerabilities. Our images are signed from a trusted registry, whether we're using Docker Hub or AWS ECR. It has passed our all admission controls. Kubernetes has deployed it successfully. Everywhere is green, right? Now the application is running normally. Later, maybe a vulnerability is discovered, right? A vulnerable dependency, or an attacker finds a way to exploit that existing dependency, and a new process starts inside. Then the process starts establishing an outbound connection. Which of these controls on the left, right, tells me what happened, right? Right. The answer is none of them, right? Because each of these guys have they are basically preventive controls, right? And preventive and detective controls are not interchangeable. Right? Preventive controls reduce the probability of a compromise, and detective controls, right, which is what we're referring to now, which is runtime detection. It helps us to identify the compromise when prevention fails, right? Um, but let's move in now. Let's just move into from an AWS standpoint. We have AWS EKS, which is an AWS managed Kubernetes cluster. Um, and when we are talking about the shared responsibility model, right? Why AWS EKS manages the Kubernetes control plane, right? Components like your API server, your etcd, your scheduler, your control manager, um, but our workloads, they say execute on compute. So when I mean they execute on compute, they execute within our own environment, right? We manage the worker nodes depending on how available that we want our applications to be. We have pods, we have containers, and definitely we have processes running. Let's imagine our operating system we're using is Linux, right? And underneath these processes, we have Linux kernels. Now, the kernel layer, right, is an extremely important, or rather, it's extremely interesting from a security standpoint, from a security perspective, and because ultimately processes have to ask kernel to do things, right? If I want to do this, if I want to do something, oh, hi kernel, this is what I'm trying to do, right? So now that's where Falco gets its own visibility. Um, Now, in terms of threats at runtime, right? Once a workload is running, there are several categories of behaviors that we care about. We take a look at processes. Did something execute that normally shouldn't? We take a look at shells. Why did someone suddenly launch bash inside my production container? We take a look at file system. Why did someone suddenly launch bash inside sorry, take a look at file system, right? Why is application reading my etcd shadow folder or probably Kubernetes credentials? We take a look at privileges. Is something trying to escape privileges? We take a look at network, right? Why is my workload trying to connect to an unexpected external host? Um, then we'll take a look at the regular Kubernetes activities, things like you're running kubectl exec or service account abuse or privileged workloads. So now, if you look at all these behaviors from an attacker's perspective or standpoints, they map naturally to techniques like, if you look at the meta attack framework, things like your execution, things like your discovery, privilege escalation, persistence, and impact. And here's one thing that we need to note is that prevention and detection solve different problems. I know already spoken about this argument initially, but I want to shed more light here. On the left here, on the left are controls that prevent bad things from happening. Right, you have your identity access management, you have your ISA. Um, your ISA is relating to identity access rules for service accounts within AWS. Um, you have your network policies, your port-to-port communication, your image scanning. The on the right are things that could help detect activity, right? Runtime detection, syscore telemetry audit logs, guard DOT for EKS monitoring and the likes. So, but then Falco here is primary detection and just something we need to understand, right? It observes activity, evaluates activity against a certain rule or rules, and generates alerts. Now, what you do with alerts afterwards is part of a broader security architecture. Now, we have been talking about Falco, but then how did Falco even come into existence? Now, let me formally introduce Falco to you. So, we understand it now. Before today, we have or rather, before now, we have understood the problem. But then now, Falco is an open source cloud native runtime security project, right? So it was primarily created by SysDig and it was later donated to CNCF, where it became a graduated project. Um, the the thing that makes Falco particularly interesting is visibility. Basically, it can observe activity at the Linux kernel level and enrich that information with container or basically Kubernetes context. Instead of simply just telling me PID, let's say a process identifier 742 executed a cat command, what Falco is going to tell me is this process ran inside this container, inside this pod, inside this namespace, using this image by this user. Right now, that context is what turns raw telemetry right into something that a security analyst can actually investigate. And how does Falco work? Right. Um, let's go let's go one level deeper. Right. At the top we have Linux kernel. Right. Like I had mentioned earlier, every time a process wants to perform certain operations, whether I want to execute a binary, open a file, create a socket, change privileges, it interacts with kernel through system calls. Now, if I run cat scd cat etc shadow file, there are Linux level events associated with executing cats and opening the etcd, rather etc shadow file. Um, Now, Falco's driver, right, captures this stream of activity. And in our lab today, we are going to be using what you call the modern eBPF probe. So Falco's libraries then process these events and enrich them with container and Kubernetes metadata. Now, the rules engine, right, what they do is they evaluate those enriched events against the rules that we have loaded. And if a condition matches, Falco generates an alert. So just to summarize all I've said in one sentence, right? Kernel events, capture, enrichment, rule evaluation, and alerts. So we have to remember that flow. Why? Because during our demo, you're going to watch it happen. Um, Now, remember I mentioned that we're going to go through a typical Falcon architecture on EKS. And here you go. So now we are we let's try to um scale. the concept we're trying to work on at the moment from just one Linux machine to an entire cluster. Here we can say that we have two worker nodes. One application pod generate activity on each node, right? Falco runs on each worker node and observes the kernel activity occurring here. Um, so when Falco detects something, we don't necessarily want the alert to remain inside the Falco pod. Yeah, we want to route it to somewhere useful. That's where something like you have your Falco sidekick. It comes in, he receives the Falco alerts and he fans them to any downstream destination. It could be CloudWatch logs, it could be your SIM, security lake, or even notification platforms like Slack, PagerDuty, SNS. So ultimately, the goal is to get an alert to whoever is responsible for investigating it. Um, but then currently as it stands, you could see here that within the slide, right, I had mentioned Falco Sidekick. Um, but then for the sake of today's demo, I've deliberately kept it very simple. Falco writes JSON alerts, and we're going to be using FluentBit instead of Falco Sidekick. I'm basically using FluentBit to write logs, or rather to forward logs to CloudWatch. Um, and now that we're deploying Falco as a daemon set, right? I'm going to explain to you what exactly is the concept of a daemon set. Like, what is exactly the daemon set? So, daemon set is like a Kubernetes concept. It's extremely important. Um, Falco isn't normally something where I say, okay, give me 3 replicas. No, I want Falco to run on every worker node I want monitored. So if I have 3 nodes, for example, right, I want 3 Falco pods. If I'm using Capital for my auto scaling, or I'm using my regular cluster auto scaling, and it has a fourth node, Kubernetes automatically schedules another Falco there. That's the essence of a daemon set, right? Something it runs across every node. If a new node is created or spawn up, right, that daemon set that I have created, the pod is going to run on that particular node. Why? Because the kernel activity we're interested in is occurring per node, not just on a singular node. And what does this give us, right? It gives us complete visibility. It gives us automatic coverage, right? We don't have to bother about starting to manually trying to install Falco within a new node because our cluster, or rather, yeah, our cluster auto scaled. Um, Now that I've spoken about Falco in general, what is Falco, why is it important, and why are we running Falco as a daemon set? The next step for us is to understand Falco rules. Um, we Now every rule has a name. Now, if you look at my screen, every rule has a name, a unique name. It has a description, and most importantly, it has a condition. So when I mean condition, I mean what behavior am I looking for? Then he has an output. An output is where information should appear in the alerts. It has a priority. The priority tells us the severity, and it could have tags, right? So tags just basically classify the detection. If we want to map it to a meta attack, right? Framework. So um, we need to pay attention to these rules, right? Because these are rules that we can easily create ourselves based on our use cases. First thing first, we need to have is a name. A rule needs to have a name. So I'll read myself again. One is a name, two is a description, right? Three is a condition, four an output, five is severity, right? And tags. Tags are extremely optional, but then based on best use cases, right, you could have a tag, right? Why? To map us to attack framework, or rather to the meta attack framework. So the meta model here is extremely simple. An event comes in, it evaluates based on a certain condition. If it's true, it generates an alert. And just proceeding to rules, macros, and lists. Now, when we talk about Falco, there are also 3 things that we also need to take notice of, right? Those are the rules. So I call them RMLs, right? Rules, macros, and lists. Um, and these are basically building blocks. So think of list as like an array, right? So instead of repeating bash, sh, zsh, ash, DSH everywhere, right? Right. I can define all of them as known shells, right? Then think of a macro is like a reusable detection logic, right? So I can define container shell as a process being spawned inside the container where the process name is in my known shells list. Then the rule just says when that condition occurs, generate and generate this alert at this priority. And this becomes very powerful in large environments where you can compose complex detections without actually duplicating your logic everywhere. Um, and more importantly, when we um, when we install Falco, right? Falco comes with its pre-built detection rules, but it's extremely important that we separate our custom detection rules from the upstream Falco rules, right? So this allows Falco default rules to be updated without actually overwriting our own organizational specific detections. Um, then in terms of from runtime event to security, so let me briefly just tell a story. Now, everything I've said, let's connect everything that I've discussed about. So imagine our application is running normally. An attacker exploits it and executes a command inside the container. The Linux kernel sees the process that's executing. The eBPF probe captures the relevant events. Falco enriches it with Kubernetes context, right? The rule engine evaluates it. Your rule matches. Falco generates an alert. We send that alert to our monitoring system, and now the SOC has something actionable to investigate. So now, notice what travels with the alerts: time, rule, priority, namespace, pod, container, image, process, user, and command line. Now, that's the difference between saying something suspicious happened and saying this exact process, this in this exact pod executed this exact command. Now, in a true life, in a production environment, what exactly is this going to look like? Now, before we jump into our lab today, right? I want to make one thing very clear, extremely clear. So installing Falco doesn't mean that you suddenly have a complete real-time security program. No. Falco is just one component of the detection pipeline, right? Your workloads generates activity. Um, the kernel provides that telemetry. eBPF gives Falco visibility. Falco applies what our detection logic. Alerts need to be transported somewhere. Now, CloudWatch logs can provide storage and alarms, right? A SIM can correlate all these alerts with other telemetry, and eventually someone within your security operations function, right, has to investigate this particular alert or event. And but then something that you need to know is that before you start slacking someone at 2 a.m. in the morning, you need to understand that you need to tune your rules, right? Runtime detection can get extremely noisy. Um, you want to give your Falco pods, you want to give it an appropriate CPU and memory budget, right? You have your limits and treat custom detection rules as code, right? Put them in version control, review them, review them, review the changes, and test them. Um, so we have spent a significant amount of time on the theory, right? Understanding what runtime security is and how it works. Now let's stop talking about it and actually attack a container. Um, so I'm going to share my terminal and I'm going to quickly stop sharing the screen. Share my terminal and my EKS. Just give me 1 sec. Um, so um, in preparation for today's session, I tried to spin up a container, um, rather a Kubernetes cluster, because it basically take me like 10 minutes. I didn't want to waste, or 15 minutes rather. I didn't want to waste our precious time trying to spin that up from ground zero. So let me stop sharing. Okay, stop sharing. and let me share the screen. New window. Okay. Um, pa, 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 pa. Okay, so just let me know when you can see my screen. Okay. Um, can anyone see my screen? Okay. Alrighty. Okay. Thanks, Kosi. All right, great. Um, yeah. So we have a sample cluster that I just spun up, right? So after this session, I'm going to share us a GitHub link that contains all the processes that I use to spin up a cluster and the commands that run as well. So it's easy for us to follow or easy for us to replicate this activity later on. Let me also bring up my terminal as well. Okay, new window. Okay, I think I might have to make this bigger. Okay, so this is my window. Let me log into my, let me connect to my AWS account. Okay, so let me connect to my Kubernetes cluster. Okay, okay. So we have our AWS EKS update kubectl region. I'm going to use EOS one. And then my cluster is AWS Study Series cluster. Okay, perfect. So let's do kubectl get pods. Okay, so we can see here that um we have some pods running, right? We have Fluentbit, like I mentioned. Fluentbit is what is going to push our logs to CloudWatch, right? And we have an Nginx container, or rather pod is just running Nginx. Um, for the sake of this demo, right, I'll also walk us through. Let me also show. There's this particular. Let me bring it up. Yeah, I think that's this. Okay. Um. Okay. I cloned this repo, right, from Sysdig Labs. I sort of made some modifications to it, just in preparation for today's session. Um, Definitely, we're working in EKS, right? So we navigate our way to EKS, Fluent Beats, um, Kubernetes, and you have a config map, you have a daemon set, and you have a service account. Now, naturally, if you want to, let's imagine now, if you ask me this cluster that I created, um, how is this cluster being created, or rather, what command did I run? Um, and it's extremely simple to create a cluster, right? All we need to do is to connect to whatever AWS account you want to connect to, right? And run this command, right? It's EKS CTL. So you are creating a cluster. This is the name of the cluster. This is the name of the region. You're creating a node group. You have your node type T3 medium. You have your nodes. You have a minimum number of nodes, maximum number of nodes, and definitely managed. You want them AWS managed. Um, After you do this, it takes about 10 to 15 minutes. So what it does is it creates a cloud formation stack. And I'm going to walk us through, or rather, I'm going to show us the cloud formation stack that was actually created specifically for this cluster. So we'll go back to our AWS environment and we navigate to cloud formation. Okay. Yeah. Two clusters were created, rather two cloud formation stacks were created. So one created the cluster and one created the node group. um it's pretty much easy, right? That's what you have. So you don't need any extra, you don't need to do anything extra. But then there's something that we all need to note. When you initially create this cluster, right, everything goes well. But then when you want to now try to, let's say you want to start creating your fluent bit pods and um all you have to do is you have this link, right? What it does is it creates a service account. It creates a service account. It creates a cluster role, right, and creates a role binding. So the real essence of this is you want to create a pod, right, that pushes um logs from a source to a destination, right? And when we talk about Kubernetes, right, every pod needs a service account, and this service account needs a rule to use, right? That's why we have what we call IRSA, right? IAM rules for service accounts. So initially, when you try to run this, or rather, when you try to deploy all these manifest files, your Fluent Bitpod is going to be crash looping. Why? Because it doesn't have the necessary permissions within your AWS environment. So what you then need to do is you need to create a policy. So if I navigate back to EKS, um, Fluentbit, AWS, you need to create a policy. And what this policy does is it creates what you call a policy that helps to create a log stream and push log events. Now, this policy will be put, or rather, this policy will be attached to a role, and this role is going to be attached to my service account for Fluentbits. Um, Now after that is done, right? What you then need to do is then to run this command, right? I'm not going to run because my pods are already running Fluent Bits. So what this does is, right, it creates a service account within this cluster, my AWS Study Series cluster, EOS1, default namespace. The name of the service account is Fluent Bits, right? The name of the role is Fluent Bits Cloud Role, and this is the policy ARN. Um, then when you mean override the existing service account, that means that whatever service account that exists, I need to override the configuration of that service account, right? So what when you do this, right, what you then need to do is now to restart your deployments. Restarting your deployment just basically means that all the Fluent Bit pods that were running initially, right? So it could be like a rollout. All the Fluent Bit pods that are running initially, right? What you need to do is it deletes them and creates new pods. Now, this is just to ensure that your Fluent Bit pod is in a running state. Um, Now let's deal with, or rather, let's go into the main um practical of today, right? What we want to do is we want to create a, or rather, we want to deploy our Falco as a daemon set, right? So let's just confirm that we have no daemon set running. Falco daemon set. Okay. So you can see here that we have no, the only daemon set that we have here is Flame Beats. We don't have any Falco daemon set or any of sorts, right? So the first thing we want to do now is to install Falco. And how do we install Falco, right? We can use Helm charts. Um, Now let's navigate our way to Falco's documentation. Um, it's extremely important that we use documentations in anything that we're trying to do. Think I should, okay, so I have a new screen. Okay. Um okay, so basically it says the deployment of Falco in Kubernetes cluster is managed through Helm charts. Right. This chart manages the lifecycle of Falco in a cluster by handling all the key subject needed by Falco. Um and first things first is we want to do is to we want to add this Helm chart, Falco's Helm charts. Um so let's run it together. Okay. So I think I need to probably um divide my screen so I'm able to do two things at once. Okay, let's have this guy right here, and let's have this guy right here. Okay, good. So we can all see my screen. Okay, so first and foremost is, yeah. So Falco security already exists with the same configuration skipping, right? Because I've already added the Helm chart initially. Then all I need to do is to update my Helm repo. So it's trying to, okay. So successfully got an update from the Falco security chart repository. Update complete. Happy helming. Now we we want to install Falco, right? What this does is it installs Falco within a new created namespace called Falco. Um, when you do this, right, like we had mentioned that it comes with its own set of predefined rules, right? And also predefined configuration. Now, there's something I want us to, like we had mentioned that Falco pushes logs in JSON, right? But then it's not turned on by default. Let's go to um, values, right? So this is where we're going to see the configuration. So basically, this all shows us all the configurations that we need, right? So if we search for JSON, um, right here, JSON outputs. right? It says when enabled, Falco will output alert messages and rules, load files, validation result in JSON formats, making it easier for JavaScript programs to process. So by default, it is set to false, and we want to set it to true, right? And also aside that, in terms of the driver, and we also want to use eBPF, right? Like we had mentioned. Um, so we also need to set that as well. Um, so let me let's go back to our documentation. Oops. So let's go back to our documentation. Um, right, yeah. Okay. Let's go back to our documentation. Okay. Um, so Helm install Falco Falco security Falco. We're going to create a new namespace. Create namespace. Name of the namespace is Falco. Um, then sorry, um, not sure why. Can you still hear me?
Hello, Ray, we can hear you.
Hello?
You,
Hello?
you're live. We can hear you.
Yeah, sorry. I'm not sure what's wrong with I think it just froze. Okay.
Okay, you're
Yeah,
back. You're back.
let me share my screen again.
Okay, so I'll go backstage.
Yeah, sure, that's fine. Okay. Um, just let me know when you can see my screen. Okay. Um, can you see my screen now? Can you see my screen? Kune, is my screen showing? Hmm,
Screen.
hello.
We can see your screen.
Okay, you can see my screen. Okay, good.
Yeah.
So next thing we want to do is to set our driver. Like I had mentioned, you mentioned that we want to use modern eBPF, right? So we have modern underscore eBPF. Um, then next we want to do is also okay modern eBPF. Okay, okay. So what this does is, or rather, Helm is helping us to install Falco, right? So you can see here Falco has been deployed. Um, also revision as well. There was something that we forgot to add. Remember, I had mentioned that by default the output is not in JSON. Um, so we need to upgrade our Helm. But before we upgrade, let me just show everyone kubectl get pods. So it's in since we created a namespace Falco. Okay, so now we can see that we have our Falcos running. Remember, we had mentioned that we have two different, or rather, get nodes O wide. We have three different nodes, right? And because we have three different nodes, that means that we should have what three different Falco pods, right, running on each node. So let's upgrade our Helm, our let's upgrade Falco, because like we mentioned, you want it to be in JSON, Falco security, Falco within the same namespace, that's Falco namespace, and we want to reuse the existing configuration. We don't want to change it to reuse values. Now this is where we set it. Set Falco the JSON underscore output to true. Now I think this is going to fail. Okay, so Helm upgrade Falco security slash Falco namespace Falco reuse values sets. Okay, good. So this will be our second revision. Pa, pa, pa. Okay, so let's just wait for it to finish. Okay, so all set, all good. Our revision is to status deployed namespace Falco. Remember you had mentioned where the default value of default configuration is, which is what you have in our screen here. So our let's go to the pods. kubectl get pods Falco. Okay, okay, it's running still in it. See, okay. I think yep, we are good. So I sort of did a beforehand. I tried to get all the default Falco rules. So Falco rules are that within. So let me just navigate to. So if we navigate to either of the Falco pods that we have, so kubectl exec it, so exec interactive session. Let's pick this Falco pod for example, um, and we sh into it. For q pods for q. Okay, that was an error. Okay, so one and a half pods now. Yep. So we are supposed to specify the namespace Falco. Yep, missed that. Okay, so we are currently in our quote unquote, right, Falco pod. And what exactly are we trying to do within this pod? We want to just try and look at the default, rather, um where is the rules, right, within this Falco pod. So if we cd into etc, cd into Falco, nope, that should be single o ls. Right, so right here we have a Falco YAML and our Falco rules on our Falco underscore rules YAML. So let me just bring this guy right here. So if you can see my screen, right, this is literally the Falco's default rules, right? Like we had mentioned, I spoke about macros, spoke about conditions, but then let's just briefly look at the rules that are set here. So I think that should be rules. Okay, so sure, rule rather. Okay, so we have a total of 26 rules, right? Directly traversal monitors file upload, or rather file read. If we're trying to read sensitive file, trusted after sign up. If notice, every rule has a description, right? It has a condition, and also if this rule is enabled, yes or no, it has an output, it has a priority and a tag. Remember, we had mentioned that there are a lot of things that are extremely important when creating, or rather when enabling Falco, right? Or rather when writing a rule is the name of the rule, right? Every rule name has to be distinct. The description, the condition, right? If the rule is enabled, what you want to get outputted, the priority and the tags. Um now I'm going to do now I think it's time that we actually start attacking our um cluster, right? So first and foremost is what we are going to do is which row should we pick? Okay. I think we even okay, let's pick exec row, right? So exec exec okay blah, blah. Okay, 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 yep, right. Yes, let's go to row name blah, blah row. Okay, let's scroll down. Perfect. Okay. Now, let's exit from this guy. Now we already have about. Let's go back. Let's check all our pods. Get pods. Names. Okay. Get pods. It's all the pods that we have. Okay. Now let's do something here. Um, remember I said reading. Let's say a sensitive folder, right? I had mentioned that earlier. So let's try to exec into any of these nginx pods and read etc. Let's try to read the etc folder, the exit shadow pod file, rather kubectl get pod. I need to get the name of the pod. Okay, so kubectl exec it. Let's pick this one for example. Copy. Let's place that right here. Then bean. Nope, that should be bean bash. Let it try an error. Okay. Yep. Let's try an error. Okay. Bean bash. Okay. So now let's try to cut Etsy shadow. Let's push it to dev null to okay. Okay, so we have done something, right? We cutted our Etsy shadow file and pushed the dev null. Now let's see if our Falco has pushed this to CloudWatch. So if we search for it, you can see it's part of our rule right here, right? Sensitive files. So let's just go to our CloudWatch, CloudWatch logs. Let's go to CloudWatch. CloudWatch. Okay. Okay. So let's go to log management, Falco, schedule log streams. Within the last, let's say, 5 minutes, right? First and foremost is we could see here that a shell was spawned in a container, right? You could see the namespace, right? You could see the name of the pod, right? You could see what shell was actually spawned, right? And we could see the username, right? So we are able to detect whenever a shell was spawned, right? And aside this, even also look at here as well, right? It says here warning sensitive file opened from reading a for reading by non-trusted program. So we can also see here that a we're able to see when a sensitive file was actually opened. Um, Basically, this config, or rather this YAML file, it gives us, I think about around, I think I had mentioned it gives us around 22 rules, or 26 different rules, right? Each rule having different things. Like this is the rule that was triggered when we read the sensitive files. Don't forget this sensitive file was added, right? And it also assigns that when a shell is run, right, or spawn, this is the rule that was triggered. Now imagine if as an attacker, right, the first thing I do is when I want to enter an environment, first thing I want to run is who am I, right? So now, but then there's no default rule, right? That checks for um who am I. Now let us create our own custom rule. Like I had mentioned, sort of we don't want to have anything to do with Falco's default rules. Like we don't want to edit or update it, right? And for the sake of that, right, we are going to do our own rule ourselves. So it's extremely simple, right? So we're going to write it together. Um, so um, so let's just look at this rule together, right? So a default rule, or rather a custom rule, right? It's in a YAML format, like I had mentioned. So you have your heading, you have your rules, right? And this is the rule, right? So where exactly this rule, or rather this program, is run within a container. You have your description, you have your condition, you have your output, you have your priority, right? And now, how do we deploy this rule? That's literally the next question that you probably want to ask. Now, let's go to our let's exit from here. Exit. Okay. Let's see the into that rules folder, see into study series. Um, okay. Okay. So we have the rules here, custom alerts. Now, there's something that we need to pay attention to. Just because we create a new rule, right, doesn't mean that the existing rule is going to delete, right? That's why we are creating it. Doesn't mean. So, as always, right, if we want to deploy a new rule, all we need to do is to run our helm upgrade Falco custom underscore alerts dot yaml Falco security slash Falco. Okay. So what this does is it creates a new rule, right? It helps to update. Okay, it says okay, Falco has not deployed releases. Okay, let's see. Upgrade field, Falco, Helm upgrade, Falco, namespace. Okay, okay, custom alert, custom alert. Okay, yeah. Seeing where the issue is. Okay, here we go. I think my screen is frozen. Just give me a sec. So Falco has no deployed releases. Okay. Um, let's try it again. Helm upgrade. Falco custom underscore alert dot yaml. Nope. Falco security. Falco security. Falco security. Okay. We're having the same error. 1 second. So let's try something. So the reason we're having this error, yep. So that's why we're having this error. So if we remember, when we had earlier installed our Falco, right? We already have Falco installed already. And we had deployed it in our Falco namespace. But then what we're trying to do, we're trying to deploy in a default namespace, which should not be so. So let's change it. So just like how we just do Helm upgrade. So we're running the same thing, right? Falco. Let's have this. Yeah, copy. So namespace Falco. I want to reuse my existing. So reuse my existing configuration, my existing values, and this is my custom alert file. Custom alerts.yaml. Yes, so this should work. So the reason we're getting an error is that we're trying to install it separately somewhere, but it should not be so, right? So you can see here now that revision is 3. Now, if we check our Helm lists, Falco, yeah, so revision 3 deployed. So that's why we're having the error. Then let's just proceed to, let's say, let's try to do who am I on a regular say get pods. Let's try to run who am I now. So let's exec into any of these pods. Keep CTL, exec, interactive. Let's pick any random this thing, and yes, to beam bash. Okay. Now as an attacker, I'm reading a shell. First I want to do is who am I? I want to know what level of privileges do I have, and I see roots. Now let's go to our CloudWatch logs and let's see if we see what command our attacker just ran. I think it should be like 1 minute ago. 1 minute ago. Okay, let's search. Okay, you know what? Let's search instead. So let's go to let's see an event to trigger blah blah. Who am I? So let's filter for who am I. Who am I commands was run in a container. Yep. Let's filter for this right here. Right. So we can see here that within this node, right, who am I command was run. We can see the pod that was being affected, the default namespace, right? Um, now, now that it's being pushed into CloudWatch, for example, now what do we do with this information? Now, naturally, right, what I'll do is I'll create what you call a subscription filter. Basically, I would want to use, let's say, Firehose, right? And from this, I can probably be streaming the CloudWatch logs to an S3 bucket, for example. And I can have my SIM pick up this information from an S3 buckets, right? And I can create detection rules off of it. Or what I could do is if my SIM permits me to use webhooks, right? I could also put my webhook as a destination for my streaming. Now, what's the benefit of what we're trying to do or what we're trying to say? Right, benefit is that you can set up rules based on your own use cases, right? Based on now, Falco doesn't replace guard duty, right? It can't replace guard duty. But then what we need to understand is both of them can run together, right? You can have because you cannot edit guard duty rules, or you can create your own rules based on your own business need, and they can both complement each other. So you can have guard duty running its own threat detection, runtime detection within your pods, right? Then you can also have Falco running as well, right? You can create your own detection rules based on your own organizational needs. But then if as well you want to have Falco replace Gadget completely, it definitely can, right? Because it's free, it's open source, it doesn't cost you any money. Um yeah, so that's really all about runtime security in EKS using Falco. Um I will make sure to upload all this to GitHub and share the link for everyone to use. Um, but I think it was really nice taking this session today. Um, thank you, everyone. Thanks, Kule. Think uh,
Okay.
yeah,
Yeah, thank you so much, Oriolua. Does anyone have questions that you want him to respond? Anyone from the chat? Okay. Okay, somebody is saying share the link. The link will be shared. Already have
yeah,
the link with you for the
yeah.
GitHub
I
repo.
yeah, I do. Let me just do that. Right. Yeah.
Okay, okay, okay. Thank you. Does anyone have any question? Okay. I think people wants to go and practice before they have questions for. Okay, so you have the repo has been shared. Uh, the repo is has been dropped, so you have it. So you can go in and go and practice.
Okay. So what I'll also do is I'm going to document all of this and push it to a centralized report that I also share as well. I think says he mentioned JSON format is false by default. What format does he use?
So okay, are you asking what format does Falco use? Okay. Can you retype the question? So that there'll be clarity.
Yep.
Okay. Okay, we are still waiting for the. Okay. So now you're saying thank you. If if Jason, I'm trying to make a meaning of this. Okay. She said if Jason is false, what does he use then?
Okay. I think I understand what you. Okay, yeah, I get what you're trying to say. So naturally, it's just in plain text. The logs from
Oh,
JSON, or rather, the logs from Falco is plain text naturally. Um, but then, um, when you have that parser, or rather, when you make the output to be in JSON, right, it's easy for your SIM solution, right, to pass those logs. That way, you can create your rules from a key value pair standpoint. What's the default format for Falco if JSON is in anywhere? Yeah, I already mentioned it's plain text. That's default. It's plain text. So
okay.
default value is plain text. Yeah. So if you don't have it in JSON, it's in plain text. And if it's in plain text, right, it's difficult for you to create detection rules based off of plain text. It's not well, notice I say it's difficult, it's not impossible, right? It's extremely possible, but then it just makes it a lot easier to just have it in JSON. That way you can say, okay, that if the rule is set to this, or if the severity is warning or critical, things like that, right? So I hope that answers your question.
Okay. Do we have any other questions? Any other question? So do well to follow us on our social media. And as we announced, the community day is in full gear. Happening October 16th and 17th. The 16th will be virtual. Well, there'll be a lot of talks, hands-on training and opportunities. Then on the 17th, we'll be live at Zoom Park, Bagada, where we'll be having speakers speak from different topics. Uh, and we'll be having, people co-sponsoring, talking about what they do within AWS offerings within AWS services. So do well to register. I think we have another question. I mean, someone wants. Okay, someone said quick one. Also, do not forget to. Okay, he's talking about
Uh,
you already. Do not forget to rotate your keys.
okay, so those keys are time bound, right? So that's
Okay,
why that's why I didn't use static access keys and secret keys.
okay.
So they're expired now, so you can't use it for anything. So
Okay, so so security in depth, practice life on
yeah, exactly.
on the go. Yeah. So thank you for everyone that joined. Thank you, Ariel, for coming and sharing your experience.
Thank you.
Container security runtime. Thank you so much, and for everyone who joined, thank you. See you next week for another great session, and do have a wonderful week ahead.
Yes,
Thank
bye
you.
everyone.
Bye.